What is going on, everybody? Welcome back to our channel Maxcotech. You are watching series Introduction to Graph Theory. We have covered all of the basics of graph theory in our previous videos of this playlist. This time we will be focusing on practical implications of graph theory, specifically focusing on wireless census networks use case data routing. We will look at how Dijkstra algorithm can be used in directed graphs in a practical implementations of data routing. So let's get started.
Data routing is defined as a process of transferring data packets from a node to any other node in a network, where the goal is to use such routing techniques that allows nodes to use minimum power during the data transferring. To achieve this, every node maintains a routing table, which tells that the message M coming from node I and destined for node J should be forwarded to neighbor node K. In order to use minimum power, we need to find the shortest path. For that, we will use Dijkstra algorithm again. In the last section, we got ourselves familiar with how this algorithm works for simple graphs, but now we are going to implement the same for digraphs. We have already studied about the trees and spanning trees, so the definition for this algorithm will be as follows. Message from any node V to destination node U, also known as sink node or the root node, should follow a path along a spanning tree routed at the sink node. So this will allow us to construct a spanning tree from all the nodes towards the sink node. That will eventually gonna make a sink tree. If a neighbor n of the node u knows about a path to another node w, then u discovers a path to w via node n, which can be simply illustrated in this way. Node n knows about w and it informs it to the node u. And eventually we're gonna let nodes tell their neighbors on the shortest path on the other nodes discovered so far. I'll put in the same example graph as we studied in our last section. Routing table is shown in the right for all other nodes directing towards V0. I have constructed the shortest path on the bold black arrowed lines in the same way as we did in the section 2 last video. These all entries in the table on the right are showing the shortest routes from the given node to the V0 node, which is our sink node. For example, if a message M destined for V0 arrives at V2, then V2 is going to look up on its table and route this message to its neighbor node V0, which in this case is our destination node. If the same message arrived at V1 instead of V2, V1 routing table will tell that forward this message to V3. And moving on, when it reaches to V3, it will gonna forward this message to its neighbor, which again is our destination node V0. And finally, M reaches its destination with the shortest path. So this table is constructed for only the sink node V0. In the same way, every node will gonna have entries in their routing table for every other sink node. As an example, look at the V2 node table. It stores the information of all the possible sink nodes and also tells us that which neighbor node we want to forward this packet and what would be the total weight of the path from this node to the destination node. If you look at the node 2 routing table V6, let's say a packet is coming to V2 which is destined for V6, then V2 knows that I need to forward this packet to V1 here. The total weight of this whole route will gonna be 13. So 2 plus 7 plus 4 makes 13.
Till now, it looks like this will be the last video of this series, Introduction to Graph Theory. I will be starting a new series on wireless census networks, where we will be applying all of our knowledge that we gained on this series, Introduction to Graph Theory, and we will get to know how and what are the practical implications of these graphs. So till then, I will see you in the next one. Take care. Bye.